It's not an exaggeration. It's not being dramatic of me as a teacher to say trigonometry starts here. Yeah? The rest of that was just getting warmed up for trigonometry. Some of this will seem weird, and you might even think I'm making things up at times. You're like, what? What are you doing? You just have to dig in to this and practice it. It's not nearly as bad as it looks. The reason for the shirt is for years, people would get a negative attitude about trig, and once they had a negative attitude about it, of course it didn't go well. Like anything in your life, once you get a negative attitude about it, it's not going to go well. You've really got to embrace this stuff. So I'll tell you where to go get a shirt if you want one. You pull it on, you pull on your I dig trig t-shirt and your I dig trig mentality, and you embrace this stuff, because there's real awakenings here. There's real moments of like, oh, that's how we're going to handle that, because there's all sorts of stuff going on here. Okay? It starts with a boring part of a lesson that is completely necessary. I've stared at this for years trying to decide if there's a different way to teach this, and I can't think of anything. You need a bunch of vocabulary, and this is basically a vocabulary bank. And I encourage you, when you're having trouble with a homework question and understanding what to do next, to go back and just reread this, because chances are the words or the instructions are right here. But they're all new. They're new words, and I get it. When there's new words, good luck, until you get used to the words. Yeah. Trigonometric ratios of any angle. That should boggle your mind. You should be like, wait a minute, I thought trig was triangles. There's only certain angles that can be in a triangle. For instance, the angle 500 degrees can't be in a triangle, can it? No, it can't. Okay, so when you see of any angle here, you should be skeptical immediately. You should be like, what? How are you going to do any angle here? Well, hey, strap yourself in. Here we go. Yes?
You said 500 degrees?
Yeah.
There's no such thing as that, right? I'm just making sure.
There is such thing as the angle 500 degrees.
Is it only
Let me demonstrate 500 degrees for you.
Okay.
And I'm not being sarcastic. I'm not being funny. I'm going to demonstrate 500 degrees. You ready?
Yeah.
90, 180, 270, 360, 450, 500. That's about 500.
Oh, really?
Yeah, so you can go around more than once. And as I do that, you're like, oh yeah, that makes sense. Things go around in circles. The Earth goes around the sun, 500 degrees. It does 360 degrees in 1 year, and then it keeps going. So that's what we're talking about here. So it's not as bad as it sounds when I throw a number like 500 degrees. How is triangles involved in this? Well, it will be. You check it out. And if you have Earth questions, like I just had the old seasons conversation with my little kids. They were interested. As the snow came, they were like, why? Why is it snowing now? How can this be happening? And so I got the globe out and I explained it to them. And trig is related to all this, about why these things happen. Feel free to try to sidetrack me on a Friday with any of those questions, because I'd love to get sidetracked by those things. Anyways, the set of coordinate axes shown on the right divides the plane into 4 quadrants. Here's your first. Oh, wait a minute. That's not the right color. December the 1st. Come on, I just reprogrammed this thing to give a nice festive green. Quadrants. Have you seen that word before? Yeah, it's possible other teachers have mentioned it when you're graphing, but not made a big deal about it. They just mentioned, oh, these are the 4 quadrants. Label them on your diagram. Okay, this is the first thing you're not going to like. You're not going to like how I label them. Here they come. 1, 2, 3, 4. I promise that somebody thought this out, how to number these, and very carefully went, what's the best way to number these? And this was the right thing to do. Will it make sense right now? No, it's going to take just a little bit for me to get to why that is true. The 1 I can explain. Do you remember in grade 7, 8, 9? And all the graphing you did was in this quadrant, because everything you were graphing, everything was positive. For instance, maybe you did the cost of a hall to rent for a wedding. It was positive number of guests and positive amount of money. We worked in quadrant 1 a lot. It's the most important quadrant. So when mathematicians were deciding how to number these, that had to be quadrant 1. That's why it's numbered like that. And I'll give the full explanation right now, although it might not make perfect sense right now. If we're going to make angles in the quadrant, they should start at the x-axis and go into quadrant 1, sticking us with counterclockwise. You're like, why wouldn't you do clockwise? I'm like, well, clockwise was just a decision by somebody. Anyways, somebody went, well, let's make it go this way. There's nothing special about clockwise. That's just how our clocks run. Like, for instance, you're used to driving on the right side of the road. Well, they don't do that in most of Europe, right? They go on the left side of the road. Why? It's just somebody decided something. Actually, I think it has something to do with which side your lance is on versus which side the reins of the horse are. Like, there was reasons these decisions were made. Well, don't imagine there's anything special about clockwise. Counterclockwise is better for our quadrants. Okay.
Good morning, St. John's. Can also visit our classes.
Hang on, something's on autoplay. I'll track it down. Is it in this one? No, is it in this one? There it is. I found it. Okay. Lots of new words coming here. I'm doing it very slowly. This is actually, we have 2 days to cover all this. I want to finish this first part today, but I'm being very careful about being slow here. In the diagram to the left, the angle theta, we use the Greek letter theta oftentimes for angles. It's a trigger. That way we have A and B and all those other letters available for other things if we want. We start using some Greek letters here. Is said to be in standard position. You could put this angle anywhere. But at some point, math people went, no, standard position will be, we'll measure it off the x-axis counterclockwise. Good reasons for this. The vertex of the angle is at the origin. I'll put that dot there. Maybe you'd like to put that dot there to go, there's the vertex at the origin. One ray, called the initial arm, I'm going to put them on there so you can see exactly what we're talking about here, is fixed on the positive x-axis. Here's the first arm of the angle. When we want to put an angle in standard position, one arm of the angle will be there, and then this arm, and now watch this. As you do angles, you were going to go counterclockwise. Now this angle happens to go here, but you can go as far as you want, and you can go around multiple times. That's what the Earth's doing, right? It's going around and around and around. So now we can do any angle, but when we're doing our analysis, we'll start at the x-axis and go counterclockwise. And it's okay right now to think, we're just doing that so we all do it the same. That's all. But there's good reasons to do it. Start on the x-axis and go into quadrant 1. That's why, okay? So this terminal arm is right there. Oh, I got to write that down. The other ray called the terminal arm. And again, this is what's going to drive you nuts. You're going to be doing a homework question. They're going, where's the terminal arm? And you're like, I don't even know what a terminal arm is. And you're going to text me. You can say, Mr. Todd, what's a terminal arm? And I'm going to be staring at my phone going, what do I do here? Because I want to answer your question. I do. I want to say the terminal arm is where the angle ends up. But I also want you to become better studiers and better note takers and better able to understand what the notes are saying. So in this chapter, every time you go to do homework, take this paper out and put it on your desk beside you. It's your guide. It's the stuff I was trying to tell you here today. So take it with you and look at it. The measure of the angle theta is the amount of rotation from the initial arm or from the x-axis to the terminal arm. But I'm going to write off the side. Please do it as well. Counterclockwise. We're not trying to mess you up. I promise counterclockwise was chosen so we could start the x-axis and go into quadrant 1, leaving us no choice but to go counterclockwise. Okay, that's the setup. And I'm going to use these words as much as I can in here. But again, if these words become difficult, you come right back to here. It's like your word bank on what the heck is going on with trig here today. If you don't know the words, this can be a little tricky. Get that joke once this chapter, and so I've already used it up there. I'd say, is there any questions? But I'm not sure what you could ask right now except, do I have to memorize all these words? Yeah, these are important words to be able to understand what the heck we're going to be doing here. Do you need more time to copy those words down? You're just filling in the blanks, right? So, let P at xy be a point. And listen, if you need something, some people need something. Some people are willing to listen to a math lesson and go, you know what, I'll just see how it plays out. I trust Mr. Todd. This is going to go somewhere. This is meaningful stuff. Other people are like, I need something to hang on to know why in the heck we're doing this. So if you want something to hang on to, let's say Pxy, you can just imagine that's where the Earth is right now. And the vertex is the sun. And if that's all we're doing today, that'll be good enough. We're just doing the math of the Earth and the sun. Okay? So Pxy is any location you want. Some dot, something we're talking about, has rotated to there. So Pxy is a point on the terminal arm of an angle theta in standard position. What's standard position? Standard position means we started at the x-axis and we went counterclockwise. That's all standard position means. If we drop a perpendicular, because in the middle of all this, you might be like, how are we going to get triangles? Why is it called trigonometry? Well, all we do is from that point is we drop a right angle, a perpendicular straight down to the x-axis. And once we do that, a whole bunch of friends come off the bench. Have I done we had another game last week with my 8-year-olds. They're insane. There's nothing better than coaching 8-year-old hockey. They come off that bench like they're on fire. I open the door and they're out and they fall over each other every time. Like, don't, slow down. Like, we start the shift with 4 guys laying on the ice. As soon as I drop that right angle down, a whole bunch of people come running off the bench. Sine, cos, tan, secant, cosecant, cotan, sine inverse, cos inverse, tan inverse, Pythagorean theorem, angles add up to 180. A whole bunch of stuff comes into the game. I can use all that in my analysis of where the Earth is, if you're following my analogy. The side opposite theta is the y. Ooh, okay, that gets, my daughter Bella Todd, she had a set of highlighters when she's doing notes, and when something really big happens, highlight in red. I'm actually lying. She uses pink. But for my story, I'm going to say she does red. I'll highlight in red. These are big moments in this lesson. The opposite is just the y value. The adjacent is just the x value. Your angles and your Cartesian graphing have just collided. They're all together now. We've put them together.
I found this on the web.
Wikipedia Cartesian coordinate systems. Let's watch what's in on this lesson. But notice it happens over here as well. Look at this is the big moment. Theta in this quadrant will be acute. But if we go into this quadrant, it's not acute anymore, but it still builds a triangle. We can still talk about the angle in the triangle, even though the angle we started with was bigger than 180. It was bigger than 90. And I hope you can see we can go bigger than 180, we can go 270, 370, we can go all around, build triangles all day, and do the angle of any triangle we want, or of any angle we want. Okay, so state the primary trig ratios for the angle theta in the diagrams above. It's like, the way it's saying is like, and you're like, well, which diagram? I'm like, in the diagrams. In both diagrams, these things play out the same. Watch, I'll do sine. It said, the 3 primary ones, the ones you knew before you started this chapter. Sine theta is opposite over hypotenuse. That's still true, that hasn't changed. But in the diagram, the opposite is y. But look in this diagram. The opposite's y. The opposite is y. Opposite is y. That's what's going to happen in all these diagrams. And the hypotenuse is r. Does my y not look like a y? Is that what you're going to complain about?
No, I was gonna say, why don't they just keep it as like O, A, and H? Because once you start, because now you have 2 x's and 2 y's, and actually no, you have 3 y's.
You're asking exactly.
Axes.
You're asking the exact right question. The reason is, if we're going to do any real analysis, that is, if I said, let's analyze the angle of where the Earth's at, and it's not just about the Earth. You're like, I don't care about the Earth. Like, I'm going to give other examples too. But if we're going to analyze that, our old version of doing angles will not be powerful enough. We want to get on a coordinate system here. And this is the way to get it on the coordinate system, is to turn the opposite into the y values, turn the adjacent into the x values. And this r, you're like, well, what's the r? Well, it's just Pythagorean theorem. R squared equals x squared plus y squared. So r is just how far is the Earth from the sun, basically. It's going to be a certain amount over in x and a certain amount over in y. And by the way, for our purposes, if you like the Earth analogy, when the x's are positive, that's when the Earth's leaning into the sun, and that's when we have like warm weather. When the x's are negative, why, that's when we're leaned away from the sun, and that's when we get colder weather. That's seasons in a nutshell, by the way. Yeah. Okay. That's always going to be true. Sine will be opposite over hypotenuse, which will be y over r. And then if you want to do cos, that'll be adjacent over hypotenuse, which every single time, look at the adjacent. In both pictures, the adjacent side is the x, and the hypotenuse is the r. And r is just the distance out, how far this point is from the center. They wanted all three primary trig ratios. Tan theta will be opposite over adjacent, which will be y over x. And so you can still read it. I won't red highlight it over top of it this time, but I will put a red highlight box over there. And I hope you're noticing that I almost never use red highlighting because I don't want to overdo it. You ever seen someone like this with an English book? Like, highlight the important phrases, and they highlight the whole page. Yeah, like, whoops, I think you missed the point of highlighting. You know, you're supposed to highlight the really important phrases. So I try and do it rarely. But this is big to what we're doing. We've now incorporated trig into Cartesian XY graphing. Those two things have now collided. Okay, lots of definitions here. Lots of stuff to know and to study. Lots of flashcards available for you. Sine theta on the front, y over r on the back. Cos theta on the front, x over r on the back. Then you flip your cards over and you study them the other way. Yeah, it's time to pick up your study game. It's time. It's time. Actually, it was time 2 months ago, but it's really time now. Yeah? Trig is easy if you know all the words and all the formulas. Yeah? Okay, some examples. Here's what the homework will ask you to do. After all that, apparently we now have the capabilities to handle this particular situation, which I will do slowly and carefully. It's crazy. The point 512, okay. Where is 512? Oh, let's really test you. It's in the first quadrant. You don't have to have graph paper this time. I know some people I have been on about graph paper, but in this particular case, are you okay if I put 512 up there? Does it look sort of to scale? I went over a little bit and up a lot for 512. There's 512 in the first quadrant, he said, right there. And I'm going to label the point 5, 12. And to get a triangle, then I'm going to drop a perpendicular. I'm going to really dramatically drop a perpendicular. My active board allows vertical lines. I'm going to draw it straight down, giving me a triangle. Now a whole bunch of friends come off the bench. As soon as I make that triangle, sine, cos, tan, secant, cosecant, hypotenuse, Pythagorean theorem, it all jumps in the game just by me drawing that straight line down there. Now, here's the unbelievably difficult step that's also incredibly easy. My question is, how long is this side of the triangle? It's extremely difficult, except it's so darn easy. 5. It's 5. It's the x value. The x value is the adjacent side. That's what I was trying to say.
Oh, it's so smart.
Yeah, I know. It's like weirdly difficult, but it's so easy.
Which
So
that means that the green line's 12.
this is 12.
Oh.
If that's 512, that's side 5 and side 12. Ridiculously easy. Now I'm ready to answer the question. It says, find the 3 primary trigonometric ratios of theta. sine theta. Yes, I could do opposite over hypotenuse. That is still true. I'm not changing the rules. But you can also do our new one, which is y over r. Same thing. So the y value here, I can read right off my point here, or I can see it right on the diagram. The y value is 12, and the radius, oh, I don't have the radius.
Is it radius? I thought it was hypotenuse.
But it's both. It's the radius out to this dot, but it's also the hypotenuse. In a second, somebody say, after we do this, we need somebody to go, how is it radius? I don't see a circle. And then I'll come back to that. Just like, oh, hold on, focus on this. How do I calculate this?
Oh, easy.
Easy?
Yeah, so easy.
What is it?
So you know it's you just do the like Pythagorean theorem. So you do
Squared and squared added.
Yeah.
Yeah, because of all.
And lots of the homework questions will use the special triangles. So test yourself and see if you can see it coming.
Mr. Cobb's also 90-degree angle.
Yeah, because it's 90, because we dropped it straight down on purpose. You're like, oh, that's why you went straight down. So that Pythagorean theorem was in. So then I can do 12 over 13, because the radius is 13. Who's going to ask the question? Where's the circle? Where's the circle? Yeah, as this thing goes around, there's a circle there. Let me see if I can get my active board to do it nicely. I'm not sure if I can. We'll see. I'm going to do a circle. Color purple. Fill white. Okay, so here comes the circle. Oh, it goes over top. Hang on. No, I need it to be clear. There. It's good. Now watch this. Big moment. Big moment where you go, this is how like, I thought we were doing trigonometry. How did circles get in here? Well, circles got in here because anytime you have a circle, if you want to measure where you are on the circle, you could use a triangle to measure that out. That's true about the Earth too. We can always measure how far over and how far up is the Earth from where it started. Okay, I'm not going to leave the circle on there because I was just trying to answer my made-up question. Why is that called radius? Because there's a circle there if this thing keeps going around. Okay, well, after you do the first trig ratio, the rest ones should be easier. Cos theta, you can think of it as adjacent over hypotenuse. I'm not changing the rules. But if it's the triangles on a Cartesian plane, the adjacent over hypotenuse will be x over r, which this time is 5 over 13. And then the tan theta is still opposite over adjacent. That's true. But that's going to be y over x if we're on a Cartesian plane, which is 12 over 5.
Do we simplify those? Or just
If they could simplify, I would, but none of those reduce.
so no decimals? Or just
Yeah, we want to avoid decimals, yes. Questions? Seemingly a second example doing the exact same thing, but there's a little twist to the whole thing in
I
this
see
one.
a negative there.
Oh, good, a circle. Straight lines. Straight lines, thank you. Little grid here, a little trig grid of my own making. The point negative 4, 3. Okay, let's test somebody. Don't shout it out. Don't shout it out. Which quadrant will negative 4, 3? Just to test you on the quadrant numbers. 2. It's in quadrant 2. That'll help you to be able to think that out. Negative 4, 3. You don't have to draw these to scale, folks. I try to because I like to be able to visualize what's happening. I go, okay, if this is negative 4, 3, then it's over here somewhere. Here's my picture of what's going on. There's negative 4, 3. Next move. Right now, I can't do any trig. There's no triangles involved. But if you drop, and I'll dramatically do it with my vertical line, draw a line straight down, and a whole bunch of friends come off the bench. Sine, cos, tan, hypotenuse, Pythagorean theorem, everything jumps in the game and can now play. And my question for you is, how long is the vertical side over here?
Negative. Oh, 3.
3. That's 3 upwards. Now, reach under your chair, grab the seat belt, put it on and pull it tight here because something's going to happen that might offend your sensibilities. You might be like, you can't do that. And you're wrong. I can. How long?
4.
Negative 4. And you're like, what? How can that be? Here's how it can be. Yes? Let's imagine. Question? Comment?
3, 4, 5.
Oh, it is the 3, 4, 5 triangle. Yeah, he's a step ahead of me. Here, let me do that right now. Let's get distracted by that right now. He says c squared equals a squared plus b squared. He's like, I am not wasting my time. I recognize this triangle. And you don't have to, by the way. There's no reason to memorize the 3, 4, 5 triangle, except that it's awesome. And if you do c squared equals, I don't want to forget what I was talking about. Hang on. 3 squared plus negative 4 squared. C squared equals 25. C is the square root of 25. C equals 5. He's like, yeah, I know that's going to be 5. Yep. This negative 4, totally allowed. If positive 4 is going to the right, negative 4 is going to the left. It's okay if you're a little offended by that being in a triangle. I'll deal with it. As time goes by, I'll explain more and more, and you're like, oh, when we see negative, we're not saying the side length's negative. We're just saying it's length 4, but it went that way. That's all. So there's a little technicality there that we're okay here with negative 4 on the side length. Now we're ready to answer these questions. They wanted sine theta, which is opposite over hypotenuse. I'm not changing the rules. I'm just adding an option here that you could do y over r, which is 3 over 5. Oh, and I'm really unhappy with something I wrote, by the way. I'd really like to fix something. I didn't do it on purpose. I just didn't expect that answer so soon. You could use C there. It's not wrong to use C, but I'd really like you to use R so you get used to what R is. R is just this length of the hypotenuse. Okay? Next, cos theta equals, it's still adjacent over hypotenuse. That's still true. But you could do it x over r, which is negative 4/5, which maybe gives you a bit of a headache now. You're like, so cos can be negative? Let's get sidetracked for just a second so you can see the bigger picture. Let's get a calculator out, and I'm going to do something interesting that, again, keep your seatbelt done up here, because this might rock your world just a little bit. Calculator, sharp calculator, initialize, degree mode, and I'm going to do cosine of 130 degrees. Brace yourself. It's negative. The calculator knows what's going on. It's looking at us going, come on, it'll be okay. Cos can be negative. All that's saying is the x ended up being negative. It's just simply telling you, by the way, this angle went over to the left when you draw it in standard position. It knows all about it. The calculator's got it all figured out. Let's not get distracted by that. Cosine can be negative. That's totally allowed. Now, today, so tan theta is opposite over adjacent, same as it always was, but in my diagram now that's y over x, which is 3 over negative 4, which you can write like that. That's not wrong. Generally speaking, we either put the negative out front or in the top. You get one negative. You can put it anywhere you want, But you might find it more convenient in the numerator. But I'm not really getting sidetracked by that. I'm just mentioning that we usually don't leave it down in the denominator like that. That's usually not convenient. That's good. We've done well. We've done a lot of trig in a short period of time. I don't know what's next. Oh, yeah, you can take your seatbelt off now. Everything will be all right for a little while now. Yeah? But if this rocks your world and maybe gives you a headache a little bit, good. Yeah? How do you know it's a good workout? You hurt a little bit afterwards. Next day you're like, woo, whoa, that was something. It's a good lesson when your brain's a little bit like, geez, what the heck was that? Yeah? Do you need more time there? Okay. Move on. All right. You should love this by the end. It's going to take a few minutes to develop, but when it's done, I'm going to give you a nice memory tool to solve a lot of this and get it straight in your head. In the first quadrant, all the x's are positive. Do you agree with that? Positive x is over here. And then all the y values are positive. That's why it's called the first quadrant, because everything's positive in there. And if you went to calculate the r using Pythagorean theorem, you'd find that the r was positive as well. If you went to quadrant number, what quadrant number is the top left one? 2. If you went to quadrant 2, the x's now have gone to negative. The y values have stayed positive. But the r is still positive. Because when you do Pythagorean theorem on those numbers, you're going to square them both, and the r is going to come out to positive every single time. In fact, I'll fill those in right now. Like, the r is always positive. The distance you are from the origin is always positive. In this next quadrant, which is number 3, the sign of x is negative, and the sign of y is negative. Both of those are negative. And the r is always positive. When we get back to quadrant number 4, x is positive and y has gone negative. R is always positive because it's calculated using the Pythagorean theorem. So we're going to square the x, we're going to square the y, and it's going to come out to be positive every single time. Okay, good. Good question. So it says sine theta equals y over r is positive in quadrants. This isn't easy. Y over r. In the first quadrant, y over r would be positive over positive. So sine is positive in quadrant 1. Yes? In quadrant 2, y and r are both positive, and positive over positive is positive. But when you go to quadrant 3, y over r would be negative over positive. That's negative. Sine wouldn't be positive in that quadrant. And it wouldn't be positive in the fourth quadrant. See, sine's only positive in 2 of the quadrants. All right, now cos. Let's talk about cos for a second. Now, if your head's getting a little sore here, don't worry. By the time I finish, you're going to like what I'm building here. I'm building something. Cos is x over r. In quadrant 1, x over r would be positive over positive. So it's positive there. What? You already jumped ahead? What's the other quadrant? 4, because positive over positive. So he's jumped ahead and saw what's going to happen here. Let's look at the other 2 quadrants just to make sure he's right. In quadrant 2, negative over positive, that's going to be negative. In quadrant 3, negative over positive, that's going to be negative. All right, take a shot at tan. Which quadrants is tan going to be positive? Is y over x, it's y over x is positive in number 1, yes. That's why we like quadrant 1. Quadrant 1, everything's positive. How about quadrant 2? Y over x would be positive over negative. That's negative. It's not positive there. But check out quadrant 3. Negative over negative. What's a negative divided by a negative? Positive. So it's also positive in quadrant 3. You're like, do I have to memorize all this? No, I'm up to something. Watch. I'm going to review this now. In quadrant 1, you should write this on, by the way. You should write this on yours. All are positive. I big A, little 2 little L's on purpose. All the ratios are positive. What's positive in the second quadrant?
Y.
Yes, but from a trig standpoint.
Oh, sign.
Sin, sine, yes. Only sine is positive. I'm up to something with the big capital weird letter there. How about in quadrant 3? What's positive?
R.
R is positive,
Tan.
but from a trig standpoint, tan. And then in quadrant 4,
Cosine.
only cosine is positive. So instead of having to do everything I just did every time you're doing a question, we could just memorize this rule. It's called the ASTK rule. It's not very catchy, is it? ASTK? It almost sounds like I'm saying a bad word there. For the sake of the rule, if we start here though, cast. Nothing mathematical about that at all, except it's a nice way to remember what's positive. Now, I write it like that. Most books don't write it with a little positive there. That's a great way to remember what's positive in what quadrant. Then you don't have to do what I did here. You don't have to go y, r, x, y over x, y over r, cosine tan. No, you don't have to do any of that. You go, this is what's positive in each quadrant. Cast, but start down here, not start there. So that's a little different than the 1, 2, 3, 4. Woo! Cast. Powerful stuff. You know what? That gets the red highlighter too. Cast rule. Everybody past grade 11 who's done any trig knows the cast rule.
How is the number 3 quadrant positive for tan? Is it because there's the 2 negatives?
Negative over negative becomes positive. Strange, right? Some of this is like, I don't really get it. But I see that. Well, negative over negative would be positive. What does that mean as far as the ratios and the angles and the triangles? Not all that's clear yet. For now, we know if we draw an angle down here, tan's going to come out. Hey, let's just try it out. What would an angle down there be? 90, 180, 200, yeah? If I go to my calculator and go tan at 200, the calculator knows the cast rule, and it comes out to a positive answer. More of that coming. We don't really need the calculator just yet, but that's what's coming in all this. All right. Oh, hey, as long as we're at it, watch this. Sine 200. I don't know what the number's going to be, but it comes out to be negative. The calculator knows all about this. Okay. Other questions there? I'm on page 4 of 7 on mine. It's going to be close. Actually, I don't know what's left, so. Oh, still lots to go. Can you tell I'm not worried about that clock at all? I don't care. I really don't care. We'll take as much time as we need here to get this stuff clear and give you a chance at it. So, next. Here's what's going to happen. A question's going to be like, what's the related acute angle? And you're like, I don't know what a related acute angle is. And you're going to text me, Mr. Todd, what's the related acute angle? And I'm going to stare at my phone and go, what do I do here? What's the right thing to do? See, the kind side of me wants to go, well, the related acute angle is the angle. I want to tell you all about it. The teacher side of me is like, check your notes. Yeah? Trying to be like, I told you about it. It's in the notes there. Look it up. Get good at this. The related acute angle for an angle in standard position is the angle between the terminal arm and the x-axis. It's okay if you don't know exactly what they're referring to, because I'm going to do 4 examples in a row of finding the related acute angle. All right? Here we go. First question. 150 degrees. We need somebody who's sort of right with me to tell me which quadrant 150 would be in. That's 2, because it's more than 90.
Yep, and it's less than
It's less than 180. Now, if that bothered you a little bit, because your angles are only so, you should start labeling your diagrams like this. That would be a really wise move if your angles are just so at this point until they get a little better. 90, 180, 270. Now this line over here is either 0 or it's 360. If that disturbs you, if I do a full rotation and I'm looking at you again, you don't know whether I've turned 0 degrees or I've turned 360 degrees if you weren't watching. 0 and 360 are sort of the same angle. I'll say sort of the same angle. Yeah. So let me label that on here. There's the 150. Now here's the question that I hope, will be easy now. Now if I read the definition, hopefully somebody can tell me exactly what the related acute angle is and be a little less worried about related acute angle. The related acute angle for an angle in standard position is the angle between the terminal arm and the nearest x-axis. How many degrees are we from the x-axis? The closest, 30. Yeah? All he did is he looked and said, okay, I'm at 150. I got 30 more degrees to go. So therefore, related acute angle equals 30 degrees. Please tell me, Mr. Todd, you've got a shortcut for, spend my whole weekend writing a related acute angle every time. If you look ahead on the table I'm about to do, yes, there's a great shortcut coming. Can we do another one? Yeah, let's do another one. Can I fit it in here? I used too much space in that first one. Somebody who's good at angles. Which quadrant is 245 in? 3, yeah. 90, 180, it's in down here somewhere. There's 245. Now we're going to need somebody right on the case here. Let me read it again. The related acute angle is, for an angle in standard position, is the angle between the terminal arm and the nearest x-axis. How many degrees? 65. Because you got to go 245, subtract the 180. Don't be shy if you have to use your calculator on these. So here, I'm already ready for the short form. Are you ready for the short form already? RAA. RAA equals 65 degrees. Let's do another one. Okay, let's do another one. 73 degrees. Which quadrant is 73 degrees in? The first quadrant, because it hasn't even got to 90 yet. I like drawing them sort of to scale so I can visualize what's going on, but it's not actually completely necessary. So there's the angle 73 degrees. This one is so easy that it's difficult. If the angle is 73 degrees, the related acute angle is just 73 degrees. That's why we like the first quadrant so much. Things are nice in the first quadrant, nice and easy. And now, 330 degrees. Which quadrant is 330 in? The fourth quadrant. If you have trouble with those angles, watch this. 90, 180, 270, 360. We only wanted 330, so that's right there. It's not all the way to 360. I'm not trying to draw it perfectly to scale. I'm trying to go, yeah, somewhere about there. Enough that I can then do my calculation of how many degrees to the nearest x-axis? 30 degrees, because it's 360 all the way around. Any questions on that? Geez, I've got a chance here. I've only got 2 more. I got a giant table to do, and then what's on the back there? Oh, yeah, 4 easy questions at the end. Oh, I'm going to make it. But do you have any questions about the related acute angle? Your question should be, why do I care? Wait. You're You're going to really care by the time the lesson's over. I'm not going to leave you today without showing what I mean by this. Do you need more time there? More time? No? My controller's not working. Complete the following table. 170 degrees. What quadrant's it in? Can you do it without drawing the picture? You don't have to do it without drawing the picture, but let's just practice a little bit. Where's 170? What quadrant would that be in? 2. Mr. Tyler, I can't do it in my head. Then don't. Draw it. Yeah, there's no reason to just do it in your head. It's just that I'm just trying to practice and push your brain a little bit on a Friday. Related acute angle. Can anyone do the related acute angle of 170 in their head without a diagram? 10. I'm going to do the diagram over here because I don't want anyone to think that Mr. Todd's telling you not to draw a diagram. That is definitely not what I'm trying to do. So I'm going to go over here and draw a little diagram for you. Here we go. And here's 170, right about there. Yeah? And that's how I forget who yelled it out, was able to get the 10 degrees because it's another 10 degrees to 180. Now we need somebody who was paying attention. Sine 170, what sine would it be? Sine. That was not well thought out, mathematicians, that you're using the same word for sine and sine. Sine of 170, will it be positive or will it be negative? Ben says positive. How do you know it's positive?
Can you use the calculator for that?
You can.
Will it like turn out to be positive or negative or whatever?
But the cast rule tells you. So you just draw the cast rule on there. So when you're drawing quadrants now, let me put a new page up here. If you're having trouble, here's your awesome trig grid with all sorts of helpers on it. Mr. Todd, I'm having trouble with trig. Good. Draw all your trig on this diagram right here. It looks like this. It's got a 90 right there. It's got a 180 right there. It's got a 270 right here. And it's got a 360 right here. And it's got a CAST. You make a book where every page has 4 of those on it and sell it as the Trig Helper book, you'll sell 1 million copies. That is a good playground for trigonometry right there. It's almost like my I Dig Trig shirt here. Yeah, I got quadrants, X, Y, and R, little X, Y. Doesn't have all the other stuff on it, but okay? That's your helper. Just draw that if you're having trouble with any of the things I'm saying here. So, sine would be positive over there. I'm just going to leave the cast rule up there and see if we can just look over at it, because you don't need to write cast rule every time. As long as you get it somewhere on your page, you're okay. How about 95? What quadrant is that in? 2. What would the related acute angle be? You can tell me how to calculate it if you want, and I'll be your calculator. Would it be 5? Oh, it's a great question. Oh, I like that answer. Oh. Yeah, we got to do better on the diagrams. I'm going to draw a little diagram over here and check out 95. And then I hope me drawing it is going to be enough to go, oh, I see. There's 95. And she said 5, which is a great answer because like, oh, 5 degrees away from 90. But we need how far to 180? Because the x-axis is what we're going to be referencing off of. 85, she says, and I'm going to write out how she got it. She went 180 minus 95, which is 85. Did you? Or did you go, oh, if this is 5, then that's 85. Which way did you do it? Yeah, okay. And then my question, cos 95, will it be positive or negative?
Negative.
Negative, because we're in an S quadrant, and only sine is positive.
Oh, so like all of those are pretty much. Oh, they all.
135, what quadrant is 135 in? It's between 90 and 180, so it's in quadrant 2. Related acute angle? How many more degrees to get to 180? 40.
65. Or 45.
45, because you go 180 minus 135. Do we always go 180 minus? No. No, just in quadrant 2 we do. And what will tan? What will the sign of tan be over there? Negative, because we're in the sign positive quadrant.
Oh, that's how you know.
The cast rule just tells you.
They're all negative.
Next one. I'll draw the picture for the next one. If people are feeling lost and confused, where's 225?
Third quadrant.
90, 180, 225, it's down there. So what's that related acute angle then? How much to get back to 180? 45. But this time it's 225 minus 180. So I don't have a rule here that you just do this. You got to draw it and look and go, okay, how do I get back to the x-axis? What's the nearest x-axis? How far away it is? This was quadrant 3, by the way. In quadrant 3, only tan is positive. So secant would be the same as, ooh, what is secant?
Cosine.
It matches up with cosine. So it would be positive down here, but negative over there. You're like, oh, I don't really remember my secant and cosecant. I'm like, I know. It's starting to build up already, right? We're only on the second or third day of trig, and all these definitions are starting to, it's flashcard time. Yeah, it's time to build some stuff to go, I got it, I got it, I got it. It's easy if you know the names. 80 degrees, first quadrant,
Everything's first.
which means the related acute angle is still 80 and means everything is positive. I didn't even look here at cosecant 80 because I was like, everything's positive in the first quadrant. 300. Fourth quadrant,
60 degrees.
60 degrees.
And negative.
Negative. How did you get negative?
His sign is in the second quadrant.
Yeah. Good. Good. If that's not working for you, let's do one slower. Let's do 205, more careful. So you see how they're getting these answers so quick. 205. 90. 180. There's 205. It's gone a little bit past 180. What quadrant is that?
Third.
2, 3. And then how would I get the related acute angle? Not what the answer is. How would I get the related acute angle?
205.
In that quadrant, you go 205 minus 180. I get 25 degrees. Now, cotan. Will cotan be positive or negative? I put on my cast rule, and it says tan will be positive. That means cotan will also be positive, because cotan is just 1 over tan. One more time through the whole thing, just in case you're having trouble. Because you're like, I don't know how they're doing them in their head. Who cares how they're doing them in their head? Just draw the diagram. 110, 90, 20 more. There's 110, telling me it's in quadrant 2. The diagram just shows you what quadrant it's in. 70 degrees. Maybe he's doing that in his head, but all he's doing in that quadrant is going 180 minus 10, which is 170. Or sorry, 180 minus 110. Got a little fast there. And then if you're not sure, you write the cast rule on it. It says only sine is positive, so cosine will be negative. Okay, that table. If on a scale of 1 to 100, you felt anything over 45% comfortable with what I was doing there, we're in good shape, actually. So don't lose confidence because somewhere in the table you got a little lost. You're like, okay, I got to slow this down. I'm going to have to draw it every time and think a little and write the cast rule on. Yeah, absolutely. What do I got? 4 remaining questions on the back? Is that right? I'm going to move that off to the side for a second. It says, find cos of 150. Exactly. And by exactly, we mean 2 things. Make this note over here for exact. No calculators. No decimals. When it says those two things, that's what it wants. And I'm going to put an arrow there to what you're going to need. And there's a hint on your page already of what you're going to need to pull this off. Here's the steps. Don't fall asleep on me. This is the question of the day. It says find cos of 150. So I first draw the angle. Where is 150?
2.
Quadrant 2. It's over here. 150. Please wake up if you've drifted off to sleep, because a whole bunch of stuff's going to clunk into place in the next couple of minutes about why we're doing all this. If that's 150, and I draw my perpendicular down there, what's the related acute angle?
30.
30, because 180 minus 50 is 30. And somebody else jumps off the bench as soon as 30 degrees appears.
Oh, the triangle.
The special triangle's like, oh, you want 30? Special triangle's like, yo, ha ha ha, I can do 30. Exactly. I don't need your calculator as long as it's a 30. You're like, what if it's 31? Well, you're out of luck. You're going to have to do something else. But a lot of the questions in this chapter will be one of these angles. The related acute angle is 30, and so I can label the sides on the triangle. The hypotenuse is 2. Beside 30 is root 3. Beside 30 is root 3. And then opposite 30 is the number 1. Now I can answer the question. Cos 150 is adjacent over hypotenuse, which is root 3 over 2. You could also do it as x over r. But the way I've set up the diagram, adjacent over hypotenuse might be a little bit easier. It is incorrect, by the way. I have forgot one thing. Do you know what it is?
Squared.
Does your x need to be negative?
The x was negative. And so cosine 150 is negative. You could get that another way. You could totally do it that way, or you could write a cast rule on there. And the cast rule says cosine's negative. Now here's me speaking not as your teacher, as your friend. When that's all done, if you've got a good calculator, I know it says no calculators, but you could go over and say, I don't know, this trig thing's sort of getting to me. Let me just check it. Cos 150. Let's see what it says. And it knows. Some of your calculators don't. Some of your calculators will go negative 0.8666, whatever. And then you might go, it's time to upgrade. It's time to let this one go. Yeah? Same as your boyfriend or girlfriend. When you upgrade math classes, upgrade your boyfriend or girlfriend. It's time to trade up, right? So maybe that's not funny. Let's try another one. I'm going to do the same dramatic stuff, especially since if you're rewatching this on the video, you might jump in at a certain time. So I'm going to do the whole thing again. Tan 210. Draw the diagram. I know some of you are getting good at saying some things, getting some answers without the diagram. You're not going to want to do these questions without a diagram. Where is 210?
Third.
90? 180? 210. There's 210. And I draw my right angle down there. So what's the related acute angle? Third. Mr. Todd, I think you're playing games. You're making all the questions come out to 30. Well, of course I am. That's what I just taught you. I just taught you about the 30 degrees, so I'm going to use it now. 30 degrees. And a couple of friends jump off the bench. They're like, hey, yo, 30? You're doing a 30-degree question? I can help. Beside 30 is root 3. Across from 30 is 1. And the hypotenuse is 2. Thank you, special triangles. Go back. Now I can answer the question.
Isn't it a negative though?
Tan of 210. Oh, yeah, maybe. I'm going to act, especially since I'm making a video, I'm going to act like I forgot that. Okay, and we'll talk about that again. Okay. Tan of 210. What's tan? But the ratio. Opposite over adjacent, if you need that. Or if you need to write it down. So I get 1 over root 3. Is it correct? Draw the cast rule on. Do yourself a favor and draw the cast rule on. And this is in a tan positive quadrant because he's right. Both the y and the x are negative, so negative over negative would be positive. So you can do it that way. You can put the negatives on there, or you can just know the cast rule. You're like, huh, is it right? Mr. Todd said no calculators. Like, I know, but how am I going to know at the end of the question if you just type it in to make sure you got it right? Well, watch, I'm going to put in tan 210. And the answer is, because you can't have root in the denominator. See, the calculator is very helpful. It's like, hey, don't forget. Show Mr. Todd this. There. Much better. Sine 120. A little faster to show this can be done quickly. As I'm doing these, you might be like, these take forever. They don't have to. Once you get better at them, you're like, okay, sine 120. 120 is over here. There's 120. What's the related acute angle for 120? 60. Now watch me. I'm not looking up at the special triangles. I know the special triangles. That's what you should do. Invest some time memorizing it because it's going to save time. Because then you're like, yeah? You just chuck them on there, making your homework go way faster. And sine of 120 is opposite over hypotenuse. Check with the cast rule to double check that it is positive. Last one. Cotan 240. A little slower. 240. Where's that? 90, 180, 240 down here. He says it's the tan positive quadrant. Put the cast rule on there, silly. And if that's 240, what's the related acute angle? 60. It's in the special triangle again. Yeah? Memorize them. Across from 60 is root 3. 1, 2. Cotan. Oh, cotan. No. Here's how I do them. I go over and I'll do tan. Thank you very much. Just give me a second with tan. Opposite over adjacent, which is root 3 over 1. Then I come back and do cotan, which is 1 over root 3. But you can handle that any way you want. And I fix that up by multiplying it by root 3 over root 3. I'll check on my calculator. 1 divided by tan 240, and the calculator knows answer root 3 over 3. Okay? So your calculator is there to help. Are these easy? No. No. But I can tell the people who practice it. If you practice it, it goes very quickly. There's a set of steps here. Reminds me of the quadratic formula, right? Very difficult, but if you practice it a bunch of times, it's the same every time. These play out the same way every time. You draw the picture, you find the related acute angle, you put the sides on, you answer the question with the cast rule. Okay? So there's a set of steps here. Any questions on those? This will get out of hand, folks. This will get completely out of hand if you don't try to keep up. If you're like, oh, I got what he was saying. I understood. It's good. You must practice this.